This review is of the Thermalright Frozen Knot 360 Black ARGB All-in-One or AIO CPU liquid cooler. It is compatible with the LGA 1700 socket. It is also compatible with Asus Aura Sync. That's the authenticate tag. So if you don't see a tag from any Thermalright product, then it may not be authentic. Let's see. Here are the fan specifications, and when you're looking for an AIO, this is important to pay attention to. First of all, you should pay attention to the speed because number one, speed will give you an estimated idea of how noisy this fan might be, and number two, it will also give you an estimated idea of how powerful it might be. So the higher the number, the RPMs, the greater the chance of louder noises and better performance. Now, as we can see here, this actually does pretty well at only less than or equal to 27.7 decibels and 72.37 cubic feet per minute of airflow. The static pressure is only 2.87 millimeters of water, so that's not so amazing. But this is not what's critical. The fan specifications are not critical because you can always buy better fans. So that's why I recommend looking at the other factors. Now, just so you're aware, it's 12 volt. They do use a 0.18 amps, and they have fluid dynamic bearings version 2. The S, don't worry about that. Doesn't mean much of anything important anyways. So the important stuff is on this side. Number one, of course, you want to make sure that the AIO that you pick is actually going to fit in your case, both over the CPU and wherever you put the radiator. Number two, you want to make sure that it's a good quality radiator, copper or preferably, but if not, then aluminum is usually the most common one. You can actually cool a computer with a radiator from most anything as long as you can cool it off with fans. But you want to look at pump noise if you're sensitive to noise. You also want to look at the pump speed. Now, there's a point at which pump speed becomes a problem, but I decided to go with a higher pump speed because that allows me a greater variety of options as far as trying to find that sweet spot for how well it's going to cool off. If it's moving too fast, maybe the cool air going across the radiator isn't going to have enough time to neutralize the heat. If it's going too slowly, maybe the heat's going to build up too much. So I would prefer to have something that has more power and then lower the RPMs on it by setting it to say 70% of maximum all the time rather than 100%. But I'm going to be, the testing I do on this and other AIOs is generally at 100%. You also want to look at how much power it's using, because if you are living in an area where electricity is expensive, well, guess what? You don't want to buy a very expensive AIO. And it's got ceramic bearing. I can't really tell you which bearing for an AIO is the best for the pump. Unfortunately, there are lots of options out there. Ceramic is an extremely common one. It's used in the aquatic pets industry as well. You can also get it with plastic. You can get them made of metal. There are lots of different options. I would say better off ceramic or metal than plastic. You also want to know what the maximum lift of the pump is. That's how high it can lift the water from the pump to wherever you put the radiator. And this is a maximum of 1.6. So that is, let's see, that's somewhere close to 6 feet, but not quite 6 feet. And then the flow rate is also an important factor that you want to look at. This has got at least, or at most 1,500 milliliters per minute. So this and this number are going to be tied to each other. Although if you have a poor quality bearing, pump bearing, or you have a poor quality impeller design, that can affect the actual flow rate. I don't know what brand of pump is used on this. Somebody recently said that their Thermalright AIO does not use the Isotech, which is not a particularly amazing pump, but has dominated the industry for a long time, and now its patents are expiring. Now, this does come with an infinite ARGB mirror effect on both the water block, which is not where the pump is on this AIO, and also on the fans. And they use the TL-E12B-S static pressure fans. High efficiency pump is on the tube, which is advantageous, and a low resistance radiator, which means it's going to be easy for the water to flow through the radiator. Now, why is this good? Well, here's the thing. If the pump is in here and this goes dry, your pump dies. If the pump is here and this goes dry, it dies. If the pump is here, and I personally would feel better if it were like in the middle somewhere, but as long as you keep this in a position where air can't accumulate in it, it's not going to go dry. So this is, for many applications, I feel like this is probably the best, or second best, because better down here, place to put the pump. So let's take a look at what it looks like inside my case. Okay, so you can see how I've got this set up. Now, I want to point out that it's better when you mount this to have the tubes at the top rather than the bottom. Even if the pump is not inside of the water block, you want that. And the reason for that is because air will accumulate in here, because it's very hard for the pump to remove the air from here. And that results in eventually the cold plate, which is touching the CPU IHS, which is the hot plate. And over time, as the air builds up and there's less and less water inside, the cold plate's going to get drier and drier, and so there's going to be less heat transfer, and eventually it's going to get so low that most of the CPU is not covered, and then the CPU will overheat, and that's bad. So you definitely want to have this mounted on almost any AIO. Don't put it with the tubes down, okay? Always put it with the tubes up if you can. If you can't put it with the tubes up, put it with the tubes on this side or on this side. Now, you may not be able to do it on this side depending on your RAM configuration, so you do have to keep that in mind when you're deciding how you want to set it up. You may also have problems with it hitting against the heat sinks over here, which are or over here, so you have to be very careful to consider all those facts. Now, you can see that there are lots of cables for this. They don't have an integrated cable system, which makes it less attractive perhaps, but it's also cheaper. There are ways to deal with that problem. Because I'm constantly messing with this thing, I don't worry about that. But if you feel like neatness is a thing, then you're going to have to turn this the other way so that the cables are back there. Then you can tie them off with cable ties or twist ties or something like that so that they're not visible. Then when you have the tubes going to the radiator, this is okay like this, but you'll notice that the pump is in a position where eventually air will start building up in the pump, and that will be bad. Sorry. So it's so high, and it's really hard, not easy to make it go down so that air can't build up in there. So you want to keep that in consideration, and ideally you want to have the tubes coming in the bottom down here instead of at the top. This will, number one, it'll prevent any air buildup in the pump, and number two, all the air will be going into the bottom of the radiator, rising up to the top and getting trapped in here. and that means you'll have very little air in the rest of the system. So that's what it looks like. Let me just give you a better angle on the fans. And I said that this is well, you can't see the other side of the fans where you could actually see the fronts. That's okay. These are mounted so that the air goes out, or sorry, goes into the case from the radiator. Why is that important? Well, quite frankly, it's important because you want to use the cold air in your room to cool off the radiator rather than the hot air that's in the case to cool off the radiator, because you're trying to cool this. Now, depending on how you position your AIO, it may have an impact on whether your GPU overheats. And that is one thing that is always going to be a challenge. The best thing to do in that situation is to make sure that there's adequate airflow for the GPU, but also make sure that the GPU is undervolted. So you'll lose a little bit of performance, but it'll help reduce the power consumption and improve how well it performs. All right, so let's move on to the next bit where we look at all the individual parts. Okay, so it comes packaged in this. So you've got your accessories for Intel and AMD mounting in here. It also comes with, if you're interested in using it, this SATA power supply, so you can run your fans and your pump or your pump on this. Although, you know, personally, I can see why you would want to do that, especially if you don't have a pump header, but otherwise, not a big deal. This is what you get, and it's kind of a mess. So you get their TF7 thermal paste, which is just fine, no problems with it, does a good job, and it's inexpensive. And you get the water block, which has a copper cold plate. You can see that was the I did a very good job, actually. I just drew some lines, 3 lines across the CPU, applied this, and it does a fine job if you make sure to tighten this down correctly. But again, you're going to want to have the tubes facing up like this, or at worst like this. And this comes off. So it depends on, this is, I believe, just for the Intel, and then there's a different one for the AMD. But you want to make sure that when you put it in, or put it on, I should say, you get it in there and then you twist it so that it's locked in place. It's still going to be loose, and that's okay. The thing I don't like about this, and you know, some people are going to hate, I can live with it, but some people are not going to be able to live with it, is all the cables. I mean, you've got the cable coming off of the water block for the lights. You've got the cable coming off of the pump for the pump. You've got all the cables coming off of the fans for the fans. Now, when you're going to install this on your computer, or, you know, even if it isn't this particular one, here's what I would suggest you do. Number 1, daisy chain together. I'm going to try to make sure all of your RGB or ARGB cables are daisy chained together. Minimize the excess cabling that's there. And then you can take, once you've got this all installed in your computer, then you can take this one and you can remove the cover and you can plug it into this. So this is a 3-pin to 3-pin. So you're just going to match up the pins to the holes and plug it in like that. Now you've got all of them daisy chained. the water block and the lights on the 3 fans daisy chained so that it's very easy for you to now just have them all turned on at one time. You don't have to use multiple ARGB headers. It's so simple that way. But don't do that right away, because you may find that this cable from the water block is going to get in the way. So you want to wait until it's convenient because it's installed. Same thing with your fans and the pump. Now the pump is not going to get plugged into the cables for the fans. This is going to, you can either put it to the pump header, or alternatively you can put it to the CPU header, the CPU fan header, because some brands of motherboards, they have a sensor that will set off an alarm if the pump stops functioning if it's plugged in to the pump header. But a lot of them don't. Now I know ASRock does, but apparently a lot of brands don't provide that functionality. So if your pump dies, you're not going to get a warning from your computer depending on which motherboard and which brand you've got. So if you want to have that warning happen, then you're going to want to plug this into the CPU fan headers instead. So again, with this is a 3-pin, okay, not a 4-pin, and you want to set it in BIOS to just one speed, not a curve, just one speed. You want it stable. You want to also daisy chain together the 3 fans, and then once you've got this installed, you can plug this into your CPU fan header, and that is 4-pin, and this makes it easy. Now, the way I've got this configured right now, all the cabling is coming off of what is in my case, the side that's facing the front, or the left side of the case. So all that cabling is visible. Now that's only because I'm testing this fan, I've been testing it for 4 months now, and so I've been flipping the fans back and forth and stuff, and it's a lot easier to have the cables just facing me than facing away from me, and so it doesn't come this way. It comes with the cables off of this side, and if it isn't on this side, just make sure that it's going to be configured in a way that is going to be the easiest for you to deal with the cables, so it doesn't look like a huge mess of octopus spaghetti whatever crap in your case. But yeah, so that's basically what it is. There's a nice radiator. It's not the densest radiator. It is but it is very good. You can see how loosely packed the fins are, but that actually is pretty darn good. And you can see that the pump is right there. And you're probably thinking, oh my God, that's such a tiny pump. How can it do its job? You don't need a big pump. I used to work in the aquatic pets industry, and I learned a long time ago that you only need a big pump if you're going to be really pushing a lot of water. Like if, for example, you have a water fountain for a pond and you really want it to pump out the water really high and far, you're going to need a big pump. But in general, small pumps, especially like in a water filter or something like that, are all you're going to need. And when it comes to an application like this, you don't want a big pump. You want something that is discreet, that is not like, I'm a pump, look at me. You want a pump that's like, hi, here I am. So yeah, so these are the parts that you get with this particular AIO. And again, other AIOs will have the pump here. A few, not many, will have it here. This is the worst place to put the pump. Yeah. Anyways, I'm not going to explain all that stuff in this video. I've already covered this previously. But let's go ahead and get this installed, and I'm going to give you some data about how it performs.
I have been, like I said, using this since I received it after Black Friday, and I've been pretty impressed with it. I thought I could make it better. So I tried some tricks I know to improve the performance. And I'm not quite done, but my initial results, and when I say initial, I've been doing testing on and off most of the time that I've had this AIO. But my initial results suggest that you don't need to put better fans on it. And it doesn't even actually matter what kind of exhaust fans you've got, as long as you've got something and there's, or maybe even if there's just enough good airflow in your case. Because I've tried it with just a Noctua A12 by 25. Then I upgraded it to the Noctua, sorry, not the Noctua, the CoolJag Everflow one that's like, it's almost 3 times better than the Noctua in terms of static pressure. It's the R121232 BUAF. And it's got a static pressure of, I believe it's 6.03 or something like that. 6.03 and 133.91 CFMs. So it's pretty powerful, and it has a maximum RPM of 3,000 versus the Noctua's 2,000. So when I made the change to the CoolJag, I thought for sure I was going to see better results. But in actuality, I didn't see better results. And I also tried putting a Thermalright bend correction frame on. That didn't make any significant difference. And in fact, I bought some Superflower Mega Cool fans, which are very, very powerful, and I put those on, and I thought, oh, for sure these are gonna just smash it, and they made almost no difference. I tried it with the Superflowers. I tried it, I mean, it's just with the CoolJag together, and even though the Superflowers are more powerful than the default or stock fans, and the Superflowers are even more powerful than the Everflow at 151.87 CFMs and 7.14 millimeters of water. So that was a killer amount of air movement, pulling air in through my radiator and then having that being pushed out by the Everflow. And yet, no significant difference was obtained. Now, I know that with some water coolers, if you replace the fans, it will make a difference. How do I know this? Because STS just did a test of the Liquid Freezer 3 from Arctic, and he added on to the Liquid Freezer 3, it's the 280 millimeter. He added 3 more 140 millimeter fans to the other side of the radiator, and it immediately pushed that Arctic Liquid Freezer 3 up the list to become one of the, I think, the top one in some situations. And even in where it wasn't the top one, it was still better than the stock Liquid Freezer 3. So I know it can be done. And I'm going to try actually to overclock my CPU and undervolt my graphics card or my GPU in order to see if I can see a difference that's significant. Because maybe at the level of heat that's being produced by my CPU right now, which doesn't get very hot. I even tried LinPack and Cinebench and Prime 95. And the highest I got temperature-wise was 79 degrees in my CPU after running Prime 95 for 1 hour and 45 minutes. So I think there's just not enough heat to show a difference. I think I've got to push my CPU harder to force it to become hotter, which is going to be interesting. But I think then I will be able to see the difference. And maybe even then there won't be a difference. Maybe I'll push it as high as it can possibly go, and it still will never get particularly hot. But there's only one way to find out. All I can tell you right now is this Thermalright Frozen Knot has got a very quiet pump that runs at 5,300 RPMs max. And it moves a lot of water very rapidly through its radiator. The fans are not amazing, but they're good enough. So I think I could probably even just turn down my pump and it would still be amazing. But that pump is working so hard. Now, here's the thing. I think it's probably better to turn down the pump and let the fans do more work. Why? Because when the pump goes, well, what are you going to do? You can't just swap in a new one. It's not like the Arctic liquid freezer. So I think it'd be better turn down the speed of the pump and let the fans do more work. Now, I know for some of you that you're like, oh, but I want it to be quiet. Okay, leave it at 100%. That's fine. All I can say right now is this may not be the best cooler out there. However, I am thoroughly impressed with what this cooler has done. And I will, when I can, do a follow-up with more information about this so that you can see the results of my tests with overclocking and undervolting. And I'm going to undervolt my graphics card because it is getting to the maximum. The hot spot's getting up to 100 or so. So I do want to try and get that under control as well. And that way I can get more performance. I can get higher scores in 3D Mark, and my score in Cinebench was, it was decent. I'm not going to lie, it wasn't as amazing as I had hoped for. But honestly, I've never really used it before, and I'm not terribly familiar with what the score should be like. So when I look at it and I see 1,197 points running the CPU multi-core test, I don't really know how good that is. Other than that, in the ranking down below that, it ranked my CPU as being number 4 with the AMD Ryzen Threadripper 2990W in number 3. That's got 32 cores and 64 threads versus my 12 and 20. And the Intel Xeon W3265M was number 2. And the difference between the Threadripper and mine was 4 points. But the difference between mine and the Xeon was, well, let's say it's almost 300, I think it is. My math isn't so good, but it's hundreds above mine. And the top one was the Apple M1 Ultra, and that was another almost 50 points above the Xeon. So I don't know if that is really indicative of my CPU being good or not, because the Ryzen 7 5800X is below that. The Ryzen Threadripper 1950X is below that. The Apple M1 Max is below mine. The i9 9880H is below mine. The Apple M1 is below mine. The 12th gen i7 1280p is below mine. So, yeah. So in my opinion, at this time, I can confidently say that I don't know how long this pump will last. I mean, I know it's not high quality as far as how long, how many hours it will last. I know it is supposed to but I don't know realistically how long I could expect it to last if I keep it in my computer. But I know it's doing a really good job with my CPU at this time. So stay tuned for the follow-up video about this frozen knot, and we'll see what happens when it faces my overclocked CPU. Okay, so talk is cheap. So I just wanted to show you some of the results that I got from my last set of tests. And this is with the Noctua in the exhaust position and the standard fans and the thermal right bend correction frame. No overclocking, no undervolting. But here's the Cinebench results for the CPU multi-cores 1197. You can see that the hottest that Cinebench 2024 got my CPU was around 68 degrees. Average hottest CPU package was 69, and the core maximum was 68. So 68, 69 degrees. And then we got a little bit higher on the CPU package in the enhanced section on hardware info, 70 degrees. The iGPU was running at 38 degrees. Now this is a test of the GPU within the CPU. So 38 degrees, that's all. And then the motherboard got up to 36 degrees. The VRMs got up to 60 degrees, which is understandable since I was working the CPU hard. Yeah. So that's what that looks like. And here are the results from the LinPack test. You can see that I got it. Oh, I'm sorry, I forgot to mention. My CPU was driven all the way to the maximum default performance of 4,563.6 megahertz. That's 100% CPU usage. Okay. And with LinPack, it only got up to 70.2%, which is 3,029 megahertz. And max, the highest score that we got on that with any of the cores was 65. And then in the enhanced section, maximum was 63. The iGPU only got up to 34. So LinPack, which I had been told was going to be stronger, was not stronger. Cinebench ended up being more demanding. All right, and here is Port Royal in 3D Mark. I got a score of 9,660. That's below average. Average is 9,778. And here are my results. The highest that we can see, 59 degrees, 57 on the enhanced section, but it did get up to the maximum clock speed of 4,563.5. And then in superposition, I got a score of 10,131. Average frames was 75.78 with a maximum of 91.05, and that was 1080 extreme. And then the clock speed got up to 11.6%, 455.2. But then again, 3D Mark is a test of the GPU, so I'm not expecting to see high scores on that, or high temperatures. And the highest temperature was 49. And hotspot on the GPU was 102. Now, if we compare that to Port Royal, the hotspot on the GPU was 101. So both of them were, making it throttle. And then the 3D Mark Speedway test was 3494. Again, I didn't have the average. It didn't show that for some reason. But the highest it got was 100%, 4563.4 megahertz. And maximum temperature it reached was 60. The hotspot on the GPU was 95. So as you can see, the Speedway test is not as demanding. Now the hot one, Time Spy. I know that 18,331 is below average. 18,971 graphics score, CPU score is 15,393, and we got a high temperature of 59 degrees. So didn't quite break that barrier, and the GPU only got up to 99 degrees. So in actuality, the Port Royal test was the hottest one of the 3D Mark tests. Now, if we look at the Prime 95, this is where I got the hottest temperatures on the CPU. The hottest one that I saw was 78 degrees. This did 99.4% usage of my CPU, 4,526.9 megahertz. And the GPU, the iGPU only got to 39 degrees. And of course, the graphics card was in the 40s because it wasn't relying on that for that test. So this kind of gives you an idea of what kind of results I got. I would like to also show you the results I got with the Everflow and with the Super Flowers. Okay, this is still with the stock fans, but with the Everflow on exhaust, and the total CPU usage was 100% in Port Royal with 4,563.7 megahertz. The highest temperature that I saw on this test was 57 degrees, and the hotspot on the GPU only got to 98 degrees. The superposition test really does not challenge the CPU, so it only got up to 12%, 492.5 megahertz, and the maximum temperature that I saw was 47 degrees. The GPU hotspot got to 98 degrees. And I'm sorry, I don't have Linpack Cinebench or Prime 95 for these yet. I did that later on. The Speedway test did get the CPU up to 100%, 4,563.5 megahertz. The maximum temperature achieved was 56 degrees. The hotspot on the GPU was only 92 degrees. And Time Spy, we did pretty good on that too. 100%, 4,563.7 megahertz. Maximum temperature was 57 degrees. Hotspot on the GPU was only 97. All right, so that's with the Everflow. So basically not a significant difference between the Noctua at 2,100 RPMs and the exhaust fan at almost 3,000 RPMs maximum. So let's take a look at the results for the Super Flower with the Everflow. Okay, so in Port Royal, now when I ran this test, I didn't have the clocks being checked, so I can't talk to you about that. But the maximum temperature that we got was 57 degrees on that test, and the hotspot on the GPU was 98. And then in superposition, the hottest temperature on the CPU was 47. The hotspot on the GPU was 99. The Speedway tests, the hottest temperature was 58, and the GPU only got up to 92 degrees. And Time Spy, the hottest temperature was 58, and the GPU got up to 98 degrees. So, yeah, you can kind of see from these results, and I'm sorry I don't have any graphs to show you right now, but you can see that these tests are less appropriate for challenging the CPU and challenging the AIO than Prime 95 or Cinebench or even Linpack. All right.
I'd like to thank Grindler at Bleeping Computer for allowing me to share my videos and posts on his website. Bleeping Computer has a lot of resources, including vetted programs, malware removal instructions, malware removal volunteers, other kinds of volunteers for IT, cybersecurity information, and more. It's a great place to go. Give it a try. Thanks for watching, and I hope you have a great day.